Good afternoon, everyone. Thanks for coming. So we are excited to talk about how to achieve the full lifecycle API management in Kubernetes with Envoy and Wasm. So this session focuses on the practical ways to secure, monitor, and control the API traffic on Kubernetes using the cloud-native technologies like the Envoy and Wasm. So this is Brandon from Akamai Technologies. I'm the Principal Technical Solutions Architect, and we have co-speaker here.
Hi, everyone. I'm Mostafa, Solution Engineer with Datadog, and happy to be here today.
Okay, let's get started. So let's begin by looking at the problems we have when we build the API service on Kubernetes. So modern API environments are getting complex. So we have to manage the routing, authentication, authorization, and rate limiting and transformation sometimes. So often it's very dynamic, and we have to think about the secure management as well. So Envoy helps this scenario. So as you know, Envoy is a famous open source to learn the proxy or ingress on Kubernetes environment. So we also need a runtime flexibility and deeper observability. So this session more focused on having the Wasm as an extended filters integrated with the Envoy proxy. And there is also OpenTelemetry to monitor everything. So it can be integrated with Envoy, your deployment, and Wasm filters as well. So they can be everywhere. So finally, the API request will go through this logic, and finally they will reach out to API gateway in front of the backend API service. So they can be in the same Kubernetes clusters, or they can be in the multi-cloud environment using the different cloud service providers. So this scenario is more focused on having Envoy as the ingress, the proxy server. So not only Envoy, so Envoy itself is a very strong proxy open source, but it is very hard to have some complex logics and policies in the Envoy itself. So that's why we added the Wasm filters. And fortunately, the latest version of the Envoy supports Wasm filters as an extension. So you don't need to install those two different platforms on your Kubernetes cluster. So after you install the Envoy proxy, there is also the Wasm filter inside. So what you have to do is to just prepare environment to have your logic with WebAssembly. So Envoy, let's look at let's recap the Envoy proxy. So it supports L3 level as well as L7 level proxy, and it can be used for the Kubernetes ingress or sidecar to access your deployment. It supports HTTP and gRPC routing and retry, and it also supports, as I mentioned, the Wasm plugin. It is supported by the latest version of the Envoy proxy. So we can add the more complex logic like the mutual TLS and logs analysis and tracing support in addition to Envoy proxy. So finally, the general architecture of having Envoy is that you can have, because TLS supported the secret on your Envoy proxy as a deployment, and you can have the TLS termination there. And finally, they will access to your Kubernetes, the backend, your application logic. So they can be in the same Kubernetes cluster. So thinking about the problem here, so this diagram again illustrates the central role Envoy plays in handling API traffic. It connects the API client to backend service, so it has many logics and policies at the edge. But to adapt this logic quickly without recompiling Envoy, we need a Wasm. So let's look at Wasm once again. It's a compiled binary format for high-speed execution. So wherever you install and learn the WebAssembly, inside the web browser or outside the web, on your cloud-native environment or Kubernetes, it guarantees faster execution time. So that's why we prefer the Wasm for having some logic in the Kubernetes cluster. Also, it gives us the sandbox runtime, ideal for isolated workload. So it is good for having more the security levels based on your company's the compliance or security policy. It powers Envoy filters at runtimes. So we can build this WebAssembly using the multiple languages based on your preference, like the Rust, Go, and C++, and assembly script, which is a TypeScript language for WebAssembly. So it supports a cloud-native and affordable environment. So it doesn't matter if you want to migrate or move the previous WebAssembly architecture to another cloud or another Kubernetes cluster. It's not a big deal. So great for extensibility. So in this session, Wasm, the sample is the extended Envoy filter. So finally, and eventually, we have the built-in filters, the WebAssembly filters on Envoy environment in the edge side. So there are two kinds of the filters. So built-in filters by Envoy Proxy, like having the rate limiting feature based on your quota management for API traffic, routing, role-based access control, JSON Web Token authentication, and etc. And thanks to Wasm extensions, you can add more complex the logics like authentication, the payload transformation. So in this time, payload transformation means that if you want to change the API paths or request headers, you can do that by having the payload transformation. And metrics tagging as well for easier monitor and control your traffic. So at last, we can have a very simple architecture like that. So you can, the API client will use the HTTPS to access Envoy deployment, which has the WebAssembly filters. And after that, you can have the HTTPS or the HTTP after TLS termination. And the only authenticated API traffic will go to API server as a deployment on your Kubernetes cluster. So the data flow is like this. So your API client will access Envoy Gateway or Envoy Proxy, like a front-end or load balancer. And they have the Wasm filter for authentication, authorization, using JSON Web Token or API key. And there is also rate limiting quota management features. And we also have the request transformation logic here and validate your API traffic here. Also, there is a routing logic based on path, header, version. It works like an API gateway. So if you have the multiple Kubernetes cluster or the multi-CDN or multi-cloud for your API server, then you can do that by having the routing logic on Envoy Gateway. And as an optional, you can have the service mesh layer here. So we can put the service deliveries, discovery services like DNS, XDS, routing discovery service or something here as an optional. We can put the security level features like mutual TLS and policy enforcement based on your security requirement. And for monitoring all of the service, you can put your OpenTelemetry here as an optional service mesh layer. Finally, the authenticated API traffic will go to backend API service running on your Kubernetes, and they do have the business logic there. And also, we can have the OTel, the observability here once again, utilizing the OTel SDK or sidecar monitoring agent. You can have more another third party, the monitoring tools or observability tools here. Okay, let's see the Wasm use cases. So, actually, WebAssembly was born to learning application inside the web browser using HTTP or HTTPS. Right now, they have some more improved features like security implementation and job trust implementation with Envoy, like it supports speed, Inspire, mutual TLS, JSON Web Token, and isolated the API gateways at the multi-tenant environment. So as I mentioned, we can have monitoring features here, and my co-speaker will talk about the observability part.
Thanks, Brandon. As you might have seen with the number of CNCF projects, and many of them are emerging, Kubernetes is stable now, but Wasm and Envoy, those are emerging technologies. And when it comes to monitoring and measuring the performance, it becomes a challenge. And to tackle that, usually we look at the traditional way, which is you have logs, traces, and metrics. It's still helpful. However, it becomes challenging. I'm sure some of you implemented observability for Kubernetes before and faced all those challenges. Coming from a monolith kind of architecture, things were very, very simplistic. Things are in one host, maybe 2 or 3 maximum. We know where the issues are. It's going to be probably networking. One of the servers are going to go down, and that's about it. When you are in emerging technologies and distributed systems like CNCF landscape, things can go down. Things, you spin up an ephemeral, containers are ephemeral. Lots of things can change very, very quickly. And that will lead to explosion in the metrics, traces, and logs, metrics, and traces, and you will find yourself sometimes lost trying to find the needle in the haystack. The main reason for this, those architectures are API-centric or driven, and with that, the classical way of looking at we call them signals, the metrics, traces, and logs can have blind spots. For example, if you run a SaaS platform and Kubernetes and you want to get very, very granular to the actual API level, or if you want to get, for example, if you have a multi-tenant in SaaS and Kubernetes and you want to get to the actual tenant or user, it becomes really, really difficult. And with that, observability does not have to be finding the needle in the haystack. We've all been there. It does not work. And guess what? Sometimes it's not a needle. It's a whole person hiding in there. And human beings are complex. And if you are telling me it's a needle in the haystack, just go and find it. Just give me an AI ops, give me a tool, give me a methodology to go and find pinpoint where my problem is. But that is not available, unfortunately. So we believe with all these challenges, the way to tackle this is to go deeper in the stack with eBPF and speak the same language with the implementation of OpenTelemetry. If you're not familiar with the OpenTelemetry or OTel for short, you can think of it as a standard as well as implementation for telemetry data. The analogy I usually use, and it's very helpful, is the expressway. I can get an expressway here in Tokyo. I expect there is a sign, speed limit, and then a stoplights in the intersection. I go travel in the weekend to another city, for example, Osaka or wherever I go. I expect very similar. So as practitioners, we can speak the same language. When I say, oh, the checkout transaction is slow on my trace. All right, I'm using different tool than yours. It's not about using the same tool, but having same standards. And the actual implementation, OpenTelemetry will provide you with what's called a collector, and it gives you total freedom if you want the back end. For example, using Prometheus today, change your mind tomorrow, want to send it to Datadog, great. Next year, you change your mind again, want to send it to another provider, that's okay too. So we can all speak the same language, and you can work on it and implement it once. You change your mind in the future, things change, it's still reporting telemetry data. And the implementation of eBPF, which is a feature started in Linux, showing some promises in Windows today, you can get to the actual kernel of the operating system, implement very small mini programs, we call them probes, and they give you telemetry data, tracing, and security. And you don't have to rebuild the entire operating system. If I want to change something today in Linux, I have to submit a PR, 6 months to a year, sometimes it gets rejected. But with eBPF, I can implement those mini programs. They have to be validated and make sure we are not doing a virus or anything harmful to the US, to the OS. All right, so we believe those are better together. Why this is relevant to Wasm and Envoy? The good news, out of the box, you get auto-instrumentation with support for OTel with Wasm runtimes. I write my code, I compile it for Wasm, and I deploy it, I get auto-instrumentation. Not all the metrics you're looking for, but you get some level of visibility out of the box with Wasm runtimes. There is some effort, undergoing effort with the Envoy project for the OTel tracer. However, it's still prototype. If you're going to implement it right now, do it at your own risk. It might break your application. But it's still work in progress. I will touch a little bit in the demo that Brandon will walk us through. We'll do a before and after scenario, one without having Wasm and OTel here. Just a request comes to a load balancer, goes all the way to the back end. With Wasm, I have the opportunity here to manipulate or transform the request while getting telemetry with OpenTel every step along the way. With that, I'm going to hand it over to Brandon to walk us through the demo.
Okay, so this diagram simply is very straightforward to demonstrate when we have only Envoy proxy on your Kubernetes cluster, and in the bottom side is after you have the WebAssembly and OpenTelemetry monitoring system on your Kubernetes cluster. So if we see that, the common points are we have two services. The first one is load balancer type HTTPS supported the service as on the front end of all the API client. After that, they will access to Envoy deployment first. And thanks to Wasm filters attached in the Envoy deployment, there will be some security logics there. And then OpenTelemetry will monitor everything happen in this Envoy deployment as well as Wasm filters. And the way how to add the WebAssembly to your Envoy deployment is that there are multiple ways to implement it. But in my session, I used the comping maps to include the Wasm, the binary format code to the Envoy deployment. And then after authentication, so there is another internal service, the cluster IP type, which support HTTP traffic, and then they access to the API backend deployment. So this is a very straightforward demo environment. So moving to our video file. So this is WebAssembly built by the Rust language. So in this, you can see that there is a my filter function here. So for only a simple demo, so this function built in, written by the Rust language, just check if there is any authorization header in the HTTP request. So if there is any authorization header there, there will be this function will pass, the API traffic will pass through the Wasm filters. If there is none, this traffic will be blocked by the Wasm filters with a negative response. And then for easier maintenance, we will leave we'll make some logs for everything. So there is another function here called the myroot. So these functions, you can see that they make some logs for starting and then configuring the lost filter. As I mentioned, so WebAssembly itself is actually running on an isolated sandbox environment. So to have some easier the maintenance or debugging, so we have the two logs about when the isolated VM virtual machine is started and when the configuration is prepared and ready to run. So we make all the things in the logs. Okay, this is a simple source code to authenticating your API traffic based on the request header. And then so all the source code are in the working directory called the demo filter and Envoy Wasm filter here. There are two directories, source code and then release code. So in the source code, you can see cargo.toml file and library.loss file. The cargo.toml is for the manifest file for having the Wasm filters. And then we can use the cargo build command to compile this source code to binary format Wasm filter. So you can see that the cargo view and the target is a kind of the directory, and then we can see that there is a very minor, 0.1 second to compile everything. So let's move to the release directory to see that if there is any other binary, the compiled code for Wasm filters. So here, you can see that there is a envoy wasm filter.wasm file, which is the binary format code after compiling your source code written in the Rust. So there are also the multiple YAML files to generate the Kubernetes resources like config maps, Envoy Proxy, and API server for demo. Yeah, that is the binary format of the WebAssembly after compiling. And let's look at the config maps, how to insert the Wasm binary format to your deployment on the Kubernetes cluster. Yeah, this is encoded the Wasm file. You can check your content here. And once again, we will go to the config maps YAML file here. So now you can see that for your deployment, there is a filter chain field here. And you can see the information here, how to add the binary format Wasm filters to the config maps to use it on the deployment. So this is called Envoy config maps. So you can see that, you can feel that all the logics are in the Rust file, the original, the source code file. And this is just adding the binary format Wasm code to your Kubernetes cluster. Okay. So let's move on. And there is also a hotel collector. They are also inside the config map. So you can see that when you add the Wasm filters as well as the hotel telemetry to your Kubernetes cluster, you can utilize the config maps announcement. Okay, this is an Envoy Proxy deployment for a simple demo. And now you can see that there is a volume mount here. and then they mount the comping maps, Envoy comping maps. So this is how your deployment can use the Wasm filters and OpenTelemetry, and with the easier way to adding the Wasm and OTA to your deployment as a comping maps, and use the volume mount command here. So let's speed up. So right now you can check the binary data, which means the Wasm filters are included in the comping maps. And we have the two kinds of services, as I mentioned. So external, the load balancer type service, and the cluster IP service for internal access. And we will utilize the load balancer type made in Akamai Cloud for the Linode Kubernetes engine. So we access this service without any authorization header. Then, based on the WebAssembly logic, it gives us the negative response. But with your authorization header, like API key or JSON Web Token, for example, you can see that there is a 200 OK the response after you have the authorization header here. And also you can see that in the response header, there is a server header here and the called Envoy. So this means that Envoy Proxy itself as a deployment on a Kubernetes cluster, they are working like a web server, like an Nginx. And they have also a server response header here to let you know that this response is made by the Envoy deployment. So this is a very simple demo, but it shows us how to build your Wasm filters and how to add your hotel and Wasm filters to your existing Kubernetes deployment. Okay.
Thanks, Brandon. So key takeaways from today's session: you have the absolute freedom to change Envoy using Wasm today. It gives you flexibility when it comes to API management. We're able to manipulate the requests, add another layer of security, or whatever your use case might be. Unified observability. We believe unified observability with eBPF and OTel can help you face that complexity that comes with emergent technologies and API-centric architectures. And Envoy and Wasm offer, together they can offer better security. We would love to hear your feedback. Any questions? This is the first iteration of this. We'd love to hear your questions. Here's a question.
Just a very quick question. What would be the difference between Wasm approach and Lua filters, except the performance? Because Envoy supports Lua filter, which allows you to write basically the same, like modify the flow. So what's the difference between Wasm and Lua filters? Why would you use Wasm over Lua?
You're saying why using Wasm filters versus what's the other type? Lua? What? I'm not familiar with how do you spell that? L-O?
L-U-A?
L-U-A.
Lua.
Lua. I'm not familiar with, are you?
Okay.
You want to answer that one?
Okay, so thanks for good question. So in this session, we prefer the Wasm filters written by the Rust language. So I don't have too much knowledge on the Lua, but what I can say at this moment is that based on our research, so the Wasm filters, thanks to its natural, the faster execution time, as the binary code format. So we emphasize the having the faster responses when it comes to web service on the Kubernetes cluster, running on Kubernetes cluster, many API client or as well as the web service client, they think the web performance is an important thing. So that's why we recommend the Wasm filters for this demo scenario. But yeah, if there is the better solutions, using the Lua, for example, why not?
I wouldn't say it's like better. It's like having the same functionality. I think Wasm is like 10 times faster because it's like compiled binary, but you can achieve the same results using Lua, and it's like available in Envoy like for a very long time, I think.
Yeah.
And Wasm is like very new thing, so yeah, that's what I was asking about.
And to your point, it will be interesting to see if there is any benchmarking happening between, I'm sure Wasm will be faster because it's high performant, of course, but I haven't seen that benchmark. Maybe we should research it.
Yeah, that would be a good
It will be
idea.
another a good talk.
Sure.
Yeah, thanks
Thank
for
you.
good suggestions. And then because we talked about observability using the OTel, why don't you have the two environment have some benchmark tests? And fortunately, we have the Wasm expert in the Akamai booth from Fermion. So she can explain about the two different technologies regarding the performance and security level or something. Yeah, so you can meet McKinsey from Fermion at the Akamai booth at the G1 booth. Thank you. After this session.
Any other questions? Okay. One more? Okay, a couple more.
We already ran out of time, but just last one question.
Okay.
Yeah, thanks a lot for the session. I have a kind of newbie question. What will be the order of the filters we specify? Like, will it follow the same order we specify in the config map for
You want to take
if we have multiple filters?
Yeah, due to the limited time, only for 30 minutes, we cannot deep dive into how to add the OpenTelemetry to our Kubernetes cluster. But as I mentioned, that we can also have announce the OpenTelemetry. It is also kind of the deployment, and you can add your OpenTelemetry to your config maps, and then the mount config maps like the volume mount on your Envoy proxy. Then there would be no problem. So yeah, it's executed very well using the OpenTelemetry. Okay.
Happy to take your questions offline after.
Yeah.
We just ran out of time. Unfortunately, we would love to hear your feedback. Connect with us via email. We are in LinkedIn and as well as the CNCF Slack channel. You have access here to the slides, both in English and Japanese. The source code for the entire demo is available as well. Go ahead, download it, fork it, break it, do whatever you want to do with it. And thanks so much for joining us today, and enjoy the rest of the conference.
Thank you.